Hi, my name is Talia. I'm a staff member at Discovery, and I'm going to help you do your homework today. So this question deals with confidence intervals with teacher salaries. And these questions are a little bit confusing because they throw a lot of random information at you at the beginning of the problem. There's like a top paragraph that's like, the average teacher salary for this organization is this. And then you get to the next paragraph and it starts giving you information about a specific state, in this case, Maine. And then they ask you a question about something to do with a confidence interval for that specific state. And so my warning to you is that you should ignore everything that is like in the first paragraph because they're just trying to throw you off. So yeah, Maine. In this question, you're instructed to, given a confidence interval and the following information, find the standard deviation of teacher salaries in Maine. And so you're given that the average salary is $34,788, the number of people they sampled was 4,900, and that you're constructing, or you have constructed, a 95% confidence interval. And here's that interval. So let's get started. The first step here is to write out the general form of confidence interval. So I'll write it here. Solve for, okay. Just so we don't forget. So yeah, our first step is to think about the general form of confidence interval. So that usually takes the form of, for a mean, which we have here, x, oh, what? Okay.
Blooper reel. Don't include that.
Let's get a new marker. I might include that, it's kind of funny.
Please don't include that. Not me turning the camera around my face.
You did?
Yes.
The general form of a confidence interval for means is based on x bar and a margin of error, which is the z-score that corresponds to the confidence interval times the standard error. And as has probably been hammered into your head, standard error is equal to SD over the square root of n. So huzzah, we can find SD. It's included in this formula. So yeah. Same thing as x bar plus or minus z times SD over the square root of n. And this here is your standard error, which is the amount that the bounds range from the central mean that's given to you. So to find SD, all you have to do is kind of subtract our average salary from the upper bound, because that'll give us our margin of error, and then use some algebra to solve for the standard deviation. So if we're doing 34807.48 minus 34788, use a calculator. You get 19.48. And the reason this works is because your margin of error is how much higher the upper bound is from your average. So now that we have our margin of error is 19.48, we can set it equal to our expression for margin of error equals z times SD over the square root of n. And we already have our n, that's 4,900. But how are we going to solve for this if we don't have the z-score? You can find this easily using Python or a z-table. Using Python, the function would be norm.ppf. And for a 95% confidence interval like we have here, we have our normal curve. And if we want 95% in the middle, 0.95, each tail is going to have half of the remaining 5%. So that's 0.025 on either side, so that the whole thing adds up to 1. So to find this z-score that determines our margin of error, like I said, we can use norm.ppf and put in this whole area here. If you want more details on how to do that, there's a different video about, I think, hypothesis testing that goes more in detail in the problem about norm.ppf and how it works. Anyway, so we want to add 0.95 plus this tail area here, and then we get 0.975. Let's get the z-score, it's the area all the way to the left of it. And when you put that into Python, you will get a z-score of 1.96. So yeah, we have that now. Our last remaining variable is SD, so we can solve. So 19.48 equals 1.96 times SD over square root of 4,900, which is, like I said, given to us in the problem. And using some simple algebra, we can divide 1.96 and then multiply the square root of 4,900 to both sides, and then you will get that your SD is equal to, let's do 19.48. All right, so our standard deviation finally is $695, and then I put 714 because I love going to 3 decimal places, but different answers are accepted depending on what rounding you did earlier in the problem. But this is your answer. A standard deviation of $695.714. Yeah, that's it.